Welcome back for the online class. In yesterday's class, we were discussed on wavelet transform and what is the importance of a wavelet transform. Now, just an overview. The wavelet transform is basically used for multi-resolution of the image. If the image contains a different components, a different resolution, it will be resolved for the purpose of image compression, image analysis. So that was the basic intention of using wavelet transform. Now, yesterday I shown with like a pyramid. Okay, it is nothing but an image pyramid. If I go from like a apex to the down, the ultimately from top to bottom you are increasing the resolution. Means image will be represented with 1 by 1, 2 by 2. Okay, each level will be represented with a j. Okay, means 2 raised to j into 2 raised to j. If the level 1, 2 raised to 1 into 2 raised to 1 likewise. Means simultaneously it will be the resolution will be getting increased from apex to the bottom. That is, now in the bottom one the image will be represented with the level j, okay, that is 2 raised to j into 2 raised to j. Okay, the symptomatic, okay, the block diagram approach has been shown here. Okay, there is a procedure will be involved for the operation on an image for the residual of the pyramid. Okay. I hope you understood this one. Now, the very important here, consider the each level will be represented with the j. Okay, that is a 2 raised to j into 2 raised to j. Likewise, we have like a p number of levels. That is, total operations we are going to consider with a p plus 1 levels. Okay, by including with the 0th level. Okay. The basic operation will be, it is nothing but upsampling and the downsampling. If you go from like top to bottom or bottom to top. Okay. Now you can see in the block diagram is a simple system for constructing two intimately related image pyramid. That is, the approximation output provides the images needed to build an approximation pyramid. Okay, that is, there is a level j, prediction residual output is used to build a complementary prediction residual pyramid. Okay, that is, the each level will be builded depends on like the approximation with respect to the previous levels. That is, the prediction level residual levels will be builded, okay, for the image. That is what we were discussing. Okay, there is an image pyramid, okay, has a residual image, and the original image which is at the base of pyramid, p approximation form the approximation pyramid. Okay, based on like a previous approximation, there is a nearby image value, the level will be created. Okay, and these are the like image pyramids. What the contents will be given here, the approximation, and the each level will be represented with a p. There is a j until we will get here p plus 1 levels of the image. Means in order to consider for the image, we are having a block diagram of a p times. Means it is a iterative fashions. Okay, that is, the image construction will be based on like iterations. During the first iteration, the original 2 raised to j into 2 raised to j image is applied as the input image. Means if I consider as a full image, okay, it is having like a, if I consider like an image of like a 512 by 512, the full image will be applied. It is not divided in the form of like a small blocks earlier. Okay, this produces the level j minus 1 approximate and level j prediction residual results. Means it will be further onwards, it will be getting divided into levels here. Okay, that is, iteration will be carry forward in the form of like j is equal to j minus 1, j minus 2 likewise. So number of iteration will be getting decreased from previous, based on like a previous iterations on the image. Okay. that is the composed, okay, there is a composed operations what we will perform on the a residual image, okay, that is the first iteration, the image to be represented by pyramids in the form of like level j of the approximation period. The following, okay, there like a 3 steps will be carried out on the image to perform the pyramid. There is the first one, compute a reduced resolution approximation of the input image. This is done by filtering the input and downsampling, that is a subsampling, thus filtered result by a factor of 2. Okay, that why we taken a factor of 2, because okay, the levels will be considered in the form like a 2 raised to j, and I hope you can get it there. Downsampling means we are dividing the images here from 512, it will go to 256 to 128, 128 to 64, 32, 16, 8, 4, 2, 1, 0, likewise. Okay, that is the basic operations what we are performing here. When we are downsampling, okay, you make sure that you should not lose the image components, for which we have to use a filtering techniques, okay, that is average filtering or Gaussian filtering to be used, since the compromisation is that you should not lose the quality of the image. Okay, in the second sample, okay, in the second step, okay, that is for the upsampling. If you are going from like a upsampling for the output, okay, there is output of previous step by a factor of 2, okay, and then the filter result. This creates a prediction image with the same resolution as the input. Okay, the previously you are going from like bottom to top. Okay, when you are going from like upsampling, there is the image will be reconstructed at the output side. When it is reconstructing, it is approximation methods. Okay, look at this one. If I consider my image will be like 1 by 1, if I want to consider with a 2 by 2, means the number of pixels will be getting more, and we need to be making with the interpolation techniques with the upsampling. That's totally, it is based on like a prediction on the previous data content. Okay, that is how we will do. Okay, that is by interpolating intensities between the pixels of step 1. The interpolation filters determines how accurately the prediction approximates the input to the step 1. Okay, that is during the upsampling. Okay, let us consider that I am in the level 1. Okay, means 2 raised to 1 by 2 raised to 1. I want to consider it for the level 2, 2 raised to 2 by 2. There is a more number of the pixels will be getting more. Means I need to be fulfill the data contents for the coming level. Okay, it will be totally depends on like a predictive. There is a prediction on the images. Okay, so that I should have a downsampled data, and there is a residual data from which the image will be reconstructed. Okay, that is in the third step, it will compute the difference between the prediction of step 2 and the input to step 1. Okay, this difference can be later used to reconstruct progressively the original image. Okay, it will be getting compute the difference between the prediction image of the step 2. Okay, since okay, it is a very much important, like when we considered, okay, that is like original image we are considered, and we have performed the operations. After the operations, we need to reconstruct the image. Okay, when we are reconstructing the original image data content and the whatever the operations we have performed, we need to be compute the difference. Difference has to be lesser. What we have performed in between this one operation is a transformation. Means we are filtering the image. Okay, whatever the unwanted signal in the image, that has to be removed. Okay, that is the difference has to be minimum. Okay, this is what the residual operations we have performed on an image. I hope you can see. Okay, this is a diagram. Okay, this is the diagram what we are getting here. Its histogram will be drawn here, the histogram of this one. Okay, similarly by performing, okay, now there is like a two images. Okay, this is a one. Okay, this is one image and second image. and it is getting reduced here. Okay, its histogram will be this one, the total histogram of this one, and its size will be getting decreased here. Okay, let us consider the 512 by 512. Now it will be considered as a 256 by 256, and it will be reduced to 128 by 128, and this will be 32 by 32. Okay, that is how the image will be getting decreased. Okay, now at each step, okay, at each step we need to construct we need to construct the histogram. Okay, that is histogram. When we consider the histogram, okay, it will indicate the number of pixels having a corresponding colors. That is how the resolution will be getting decreased. Okay, that will be indicated from the histogram. Okay, this is how, okay, the image size will be getting reduced from the larger to the lesser. I hope you can see it will be look like in the form of like a pyramid. Okay, pyramid. Okay, that is the size of the image will be decreased, and the resolution is also getting decreased. Okay, I hope this makes a contents, okay, easier for you to understand. Okay, now we will come to the Harr transform. It is a very much popular wavelet transform operations. How we will perform it like a discrete Fourier transform. It is one of the techniques on the wavelet. Okay, this is about the history on this one. Okay, it is like 70 years before the wavelet transform was born, and it is expressed in a matrix form. Okay, like how we will express the discrete Fourier transform in the matrix form. Okay, similarly the operation will be performed. The oldest and simplest, okay, is the only one wavelet basis which holds the properties of orthogonality. Okay, that is anti-symmetric and compactly supported. Okay, now there is like a equation will be operated behind the wavelet transform. Okay, that is okay, like okay, that is a T is equal to H F. Okay, that is H raised to T. H raised to T. Okay, that is where F is the image. Okay, understood this one. Okay, this F is the image on which we will be performing Harr transform. Okay, H is an n by n Harr transformation matrix, and T is a resulting n by n transform. There is a transform of the H. Okay, like H will be like, it is also in the form of like a matrix. It is a transformations H raised to T. There is a transpose of this one. That is a transpose of the H. For Harr, that is a very important is that for Harr transform, H contains the Harr basis functions. Okay, it is represented in the form of like a basis function. That is in this one, in this equation, H will be the Harr transform matrix. Okay, they are defined over the continuous closed intervals between 0 to 1. Okay, that depends on like operation. Okay, the matrix of like a Harr. Okay, that is H. It will be depends from 0 to 1, and for the value of from any value. Okay, 0 to 1. That is a Z value. Okay. Now the size of the size of the Harr transform can be varied from any size. Okay, any size between 1 by 1 to n by n. Okay, let us consider. Okay, there is a simple Harr transform equation what we have taken here in this way. Okay, H naught will be root 2 divided by 2 root 2 divided by 2. Okay, I hope I can write like this. Okay, root 2 divided by 2. Okay, root 2 divided by 2. Okay, H1 will be minus root 2 divided by 2 root 2 divided by 2. Okay, now these are the coefficients. That is what the coefficients will be operated on the image. Okay, that is what you can see in the block diagram also. If I consider is the x of n is the image. Okay, H naught will be having a coefficient root 2 divided by 2. Okay, H1 will be having a coefficient here. Okay, either you in this one, Okay, you can see there is a down arrow, means you're performing with like a down sampling on the operations. Okay, now how long you will be performing? Until you reach with the level J. There's a one by one level. After performing this one, again we need to be reconstruct by using the up transform. There's a up. This will be something like, okay, this is what the operations we are performing for the down sampling on the image by using H0 coefficient and H1 coefficient. That's a Harr transform. Okay, simultaneously when we go from like a bottom to top, okay, that's the down sampling operations. Okay, now image will be like a performed with the operations. There is a wavelet operations will be performed here. Again we need to construct with the upsampling techniques by using 2 raised to up. I hope you can see there is arrow will be up here. Okay, the whatever the data what you obtained here. Okay, now here constructed here like this. Okay, now you went in this way. Okay, now I have to go in reverse fashion. Okay, when we are going in the reverse fashion, these are my coefficients. That is a G0 and okay, G0 and this will be like a G1. Okay, sorry for this. Okay, that is a G0 and a G1. Okay, they are supposed to be performed in reverse. There is a apex to the bottom, means you are increasing the number of samples. Okay, likewise, okay, this is what H0 operation will be performed, and H0 H1, G0 G1 operations, and these are the coefficients are mentioned here by using the equation, that is a H. Okay, that is a T is equal to H F H raised to T. That is a Harr transform. It will be H0 H1, G0 G1 are available, are in the form, it is represented in the form of like a matrix. There is a 2 by 2 matrix. If I consider with a 4 by 4, the more number of coefficients will be increased here. Okay, that will be the derivation is given. Okay, but as of now we will be considering only with a 2 by 2 matrix. Okay, now if it is available with like a H1 or H2, H4. Okay, now if I consider this will be like H. Okay, H1 it will be like a 1 by 1 matrix. H2 there is a 2 by 2 matrix. H4, okay, you don't like a 3, there is a 4 by 4 matrix. Okay, the 4 by 4 matrix, if I take H2, now this will be represented with the H2. Okay, that is a one. Now if I consider this one, okay, now it is represented in the form of like a matrix, that is a 2 by 2. Okay, 2 by 2. Okay, now from this one also, okay, there is like there is a procedure will be available behind this one. You can construct a 4 by 4. Okay, you just represented this one in the form of like a matrix. You will be end up with like a filter coefficients, and you apply on the image. Okay. Now this is what. Okay. Now I hope you can see the image and each image corresponding. Okay. Now very much. Okay, the basic operations will go into this block. Okay, now this is a full block you can consider. Okay, now you can consider this is a small block. Okay, it is divided in the form of like a small segments. Okay, like this. It is getting increased here. Okay, in the bottom way you are having the image. Okay, now I hope you can see. Okay, in this one, okay, in the first block I done with like a you are divided the image in the form of like a small boxes. It is initially it is divided in 4 blocks. I hope 1, 2, 3 and 4. In the first block, okay, there are 4 blocks are 1, 2, 3 and 4. In the first block I have divided in the form of like a smaller blocks in the sense I go again. I'll draw with the image pyramid. I'm going in this fashion. Okay, just I consider only for the first segment. Okay, that is divided in 1, 2, 3. Okay, again there is a one segment. I have taken with a 1, 2, 3, 4 blocks. Okay, means as if like you are going with the like a down sampling on the image. Okay, now in this previous. Okay, now in this one again you can perform the same operation. What you perform here, down sampling. Okay, 3 you can perform here, 4 you can perform here. Now you're performing means you're operating on the wavelet transform on the full image. Okay, once the operation is completed, we need to be reconstruct. How we reconstruct? What are the smaller components? The smaller components you have performed the wavelet transform. Again, you need to be construct with like in the there is a from apex to the down means upsamplings. Okay, means we need to reconstruct the image. Okay, after reconstruction, your image will be look like this. Okay, what the ultimate operations you have done here? You perform a set of operations, that is a downsampling and upsampling. Okay, if you perform for the downsampling means you reduce the image, you can use it for like image compression because the size of the image is reduced. Okay, that is what initially in the beginning I told. It can be used for like a number of applications. Okay, similarly in the upsampling, okay, the image will be filtered out. Means the clarity in the image will be okay. It is quality of the image is improved. That is what the basic importance what is performed on the multi-resolution. Okay, this is what the techniques behind a wavelet transform is operated. Okay, I hope you understood this one. Okay, from the diagram it is very much clear. Okay, you consider that full image. Okay, just I am repeating for a minute. Okay, you consider the full image. This is my full image here. It is divided in a form like a 4 boxes. Again the a single block, again it is divided in a form like a multiple small boxes. Okay, you perform the operations by using a Harr transform. Okay, and what are the operations? Okay, you perform, the image will be reconstructed, image will be found, it is a filtered image, again you reconstruct, so that you will end up with like a original quality of the image is improved. This is what, okay, it is the operation behind, okay, wavelet transform and the importance in the various applications. I hope you understood this one. Okay, now this will be the end of a multi-resolution. Okay, the techniques behind the digital image, okay, to perform on a number of applications. Okay, thank you.